So welcome to July TriEmbed meeting. No newcomers. We don't need to do introductions. Any announcements?
So Nick and I went to one of the Alamance County listeners group meetings. No, it was
Tuesday.
Yes, it was a Tuesday,
It was a maker.
and it was a maker meeting, and it was in this little tiny structure. It was in this little tiny structure in where were we? We were in Burlington on the outskirts of Greensboro.
Yeah.
Yeah, I think we could almost see Greensboro. And
We wanted to.
there were some astonishing presentations. One of the attendees is kind of an amateur mathematician and has been beavering away on an algorithm to do with figuring out or kind of predicting prime numbers for some definition of prediction. And I gave us a demonstration, and
Using a quantum computer? No.
This is just pencil and paper.
Well, computers.
Well, I mean, he's using a computer to test, and he used the term zeta function a number of times, and I read about those. It's like quantum. If you think you understand quantum, you're wrong. It's zeta function. So apparently extremely difficult to handle. And then one guy went over problems to do with a drone and some kind of gadget that was added to the drone that and fundamentally they had an absolutely incompetent power supply setup, and
we were quiet.
The noise, we were very polite, and the noise from the motor control. They were trying to run sensitive electronic equipment on the same power bus as the motor controller, yanking on the motors and turning the motors, and he talked about trying to put in bypass capacitors and so on.
Ooh, bypass caps.
But actually, the problem the avenue they were actually exploring was to try to prevent an overvoltage situation. So I think that's what was really killing and in fact they destroyed one of the Raspberry. No kidding. Well,
You mean,
or something that would effectively prevent the transients from getting to the electronics, like an MOV, for example.
there are ways of handling this.
Yeah. But anyway, no. Another gentleman showed some astonishing woodworking. He had made this perfect sphere of wood, starting with a car bumper. Starting with a rectangular block of wood, and he was using some kind of a technique involved with measuring. Was it like 1/3 of pi?
Yeah.
1/3 of pi using using dividers to mark it. Again, it was amazingly complicated. I mean, amazingly hard to wrap around. It was
The formal mathematics were
non-trivial, and and at this point you just have to trust it's going to work, right?
He was also amazingly talented.
Oh, yeah.
Yeah,
It was
just
amazing. And what else?
Was this like
There was,
hand carving or was he using?
no, he was using a lathe,
using a lathe?
but he was positioning the thing and doing these operations according to him. He does glass blowing and brought in a very, very attractive vase that he made. I may describe all of this again, ethical as heck stuff, ethical as heck stuff, details to do with how you cause the glass cooperate and get it to this shape that he had made. So it was quite entertaining and interesting. It's about right about, I remember right, 50 minutes drive from Apex, from his house.
Yep.
And so it's not too bad. The traffic's pretty fierce, but
Certainly got more.
I came here from the Boston area. Right?
I've driven around Boston.
Really aggressive, and there's plenty of traffic. But
Yeah, they're a good group. They meet usually on Thursday nights, which is
they're two different
they're two
groups.
groups.
that's right. There's the EMP
Yep.
and they're the Maker of Guild.
Right, and we were, I think, at the Maker.
With the makeup,
Yeah.
and it's
The EMP
It's
one
online.
was virtual.
Yep.
Yeah,
It's virtual.
Yep.
yeah, it's online.
So what's EMP stand for?
Like
Electromagnetic.
Yeah, it's
That's what I'm saying.
electronics, some mechanics, and
Yeah.
programming.
Oh, okay.
No, it's electronics, microcontrollers, and programming.
All right.
So-
So you attended the most recent meeting.
yeah, I
I
attended
was
the virtual
intended
one.
to, and then I was kidnapped,
Yeah, and forced to sit in the swimming pool drinking,
drinking
smoking fizz or something. It's
alcohol-free stuff.
yeah, it was I'm sure cool. But yeah, they're
So what was that meeting like?
there was a long discussion with the guy that does the woodworking about making a power supply to run a burning pen, and there was extensive discussion about the difference between volts and amps. And he is a philosophy professor, and the subtleties of power supply were not. We kind of went round in a lot of circles regarding volts and amps, and
Got a real charge out of it, huh?
yeah, it was that's that's my recollection. But nice guy. I mean, I really the guy that runs it has there's an STM neural board, which I have one coming. He is doing some stuff to do with trying to get an AI program to understand sign language. And that's one of the examples. And he and one other guy are working on that. And, I'm doing some other stuff with the board that I have, but I will let you know how it works out. They're like couple hundred bucks, and they're basically it's very similar to a GPU, only it's designed for neural processing. Some of the stuff I'm doing with biological response is, I think, might be
So anyway, they're very interesting
Yeah,
guys. It was a lot of fun.
yeah, it's
And I recommend it to everybody.
Yeah. I have the next Maker meeting, so when it is, I think I will bring a power supply with me, and we can actually asking, how do you know how much power a power supply will put out? How do you know how much power a power supply will put out? We'll just keep on putting out power forever, and
So,
And I've been to a couple meetings, and it's, many of them end up being somewhat teaching sessions with him about the same thing. So I'll bring a power supply and see if we can actually do something and get him a little. And maybe I can learn to involve snaps. Who knows?
so,
Measured in coulombs and what else?
Oh, no. Coulombs are, it's,
that would be
That's
cool.
way over his head.
Wouldn't that be cool?
no. Coulombs are, it's, and I'm going to get into coulombs because I got some coulomb stuff here. But yeah, no. It's, yeah.
So when he was teaching the kids the differences,
No, he wants his pen to be red hot, and so I'm going to bring a power supply and make his little wood burning thing red hot. Work out how many volts and how many amps it takes, and that.
Okay, here's an announcement. It's slightly no, it's not really premature. There's going to be a ham fest Saturday, August 15th at 9:30 a.m. in the morning. And it'll be at Ridge Road Baptist Church in Raleigh, 2011 Ridge Road. And it's about the time that the Cary Amateur Group does their Amfest. I think maybe this has superseded it. I haven't kept up with the changes. So
It's swap meets. It's swap meet kind of a.
yeah, it's a Hamfest swap meet. And then
But it costs money to attend.
it does. It says free. No, it's free. Sorry.
Okay, they changed it then because they've used that location before, but
Oh, okay. Well, of course, the Raleigh Hamfest is not free, but the Hamfest is not free, but it's on a 2 or 3 orders of magnitude different scale. The Cary one used to be at River Park in Cary, off Riverfront Road. And this seems like maybe it's kind of a transmogrification of that event.
My favorite one is at Draper Labs, but you see all sorts of things. You have no idea what they are there, but it's run weekly.
That's a hell of a community.
Yes.
August 9th, Sunday.
Sorry, August the 15th, Saturday, 9:30 a.m. Ridge Road Baptist Church, 2011 Ridge Road, Raleigh.
Right. This fall, here at the Forge, they are planning on doing another robot competition. This one will be a maze solving competition of some sort. Details will be leaking out over the next few weeks. Details will be leaking out over the next few weeks. I started building a robot, kind of knowing how it's going to be set up, but not the details yet. Not large enough. I'll show you in studio. So you're in studio in the robot. Make sure you can go from there. Anything else? All right, problem of the month. Ever seen this before?
Two times.
Yeah,
Nothing. You broke it, so you were here last.
My son-in-law, my grandson, started this. He doesn't wake up from deep sleep.
oh no, is it rank?
Sleep.
Oh no, is it rank Photoshop?
So I'm gonna put it back into the laptop.
I saw the white blinked And now the white is lit, and the reds are lit. Everybody's lit.
Everybody.
So it's working.
And you unplug it and it stops working?
Well, let's get at it.
Oh,
So the battery is there. If you leave it alone, it will snore, and then after another couple minutes, it will go to sleep. When I go to sleep, I set a wake-up timer. 5 minutes is what it's currently set at. Normally,
I hear a snore there.
normally I want it to be 12 hours. So it's up a couple times a day, and of course it's battery voltage.
You're kind of showing your stomach there.
So it is not in sleep now. If I press it, it will wake back up and start the timer over. So we'll give it another minute or two. When I had it plugged into the laptop, it would go to sleep. If I could press the buttons, it would wake up. Did that several times. I then unplugged it.
Battery charge is okay.
It's kind of sealed in there. It's got a pretty big battery. It ran fine with it unplugged, so it's not dead yet.
I'm just wondering if
I have. So the problem is, how do you debug deep sleep issues?
He's the man.
Maybe he's the man.
is it the ESP32?
He's the ESP32
and it's not an 8266.
C3.
I think.
Single processor.
Well, maybe it's not. Hang on. Where's my? No, it's an S3.
S3.
Dual extensor. What's it called? It's Tensilica. Yeah.
I don't have a loop. Cooper 71171 or whatever. Just use a single core. I'm sure that Wi-Fi and other stuff is being run on that core. When it wakes up, it reports that whether it woke up by the timer or the GPIO pin press. If it doesn't wake up, it doesn't wake up. The output on the serial port, the serial monitor and the IDE usually misses the first 6 or 7 lines of stuff. So I don't have the first little bit, but I print why it woke up several times so I can make sure that I can see why.
Is there anything in NRAM that may give you a hint as to what is going on when it's sleeping that you could look at later?
Okay, I have no experience in it, but
You want to move it a little farther away
I
from
can
you.
mute you, but I don't think I can unmute you.
Farther away from you.
Mute you, but I don't think I can unmute you.
okay, well,
How much of the,
the keystrokes are getting into the
how much program memory
Yeah, I understand.
do you use in the loop?
I'm just going to try to get it, see what happens. So no, it had not gone to sleep.
oh,
Because the battery is still. How much memory do
So what are your tricks, Nick, for
Well, I would set up
getting sleep?
a virtual disk and write the data, write what happens onto the log file on the virtual disk. It's, you know,
when it's not, I am using 36% of
then you've got plenty,
program storage,
then you've got plenty of room to,
24% dynamic memory.
you've got plenty of room to set up a virtual disk in program storage and write events to the virtual storage and write events to the virtual disk.
All right, and it'll see, I'm going to sleep.
Well, it
Maybe there'll be more, I don't know.
okay, but it will go when it wakes up. It should give you a reason why it woke up.
Yeah, it's not waking up.
It's not waking up.
Yeah, the bug is that when it gets into the bad state,
And
it doesn't wake up.
I don't think it wakes up every 5 minutes. So I think either the timer or the GPIO cover works. So it's in some other
Oh,
sleep state.
okay, I have a hard question. Okay. Can you bisect you get?
So
and
the
determine-
first thing I did is I
determine
tried
what
to,
changes?
so let me tell you a couple of things that have happened. I want this to work here in Raleigh and in the mountains. So when it wakes up to report its battery voltage, it doesn't turn on the lights, it doesn't turn on the speaker. It says, I woke up my timer, and I'm going to attach the Wi-Fi and send my MQTT message and go back to sleep. The SSID is different for the two locations. So it thinks it's in Raleigh or the mountains. And so it will try the SSID, did it where it thinks it's located, all the Wi-Fis that it can find, and it looks for the names of things that it knows. And if it finds it, it changes over to that, goes to sleep, and the next time you wake up, it should be able to log in. So that behavior I have added.
You were discussing that earlier.
And so the issues seem to start happening since I have that logic. I have also upgraded my ID and my ESP library files. Loaded around the same time.
I did that recently up to 5 and have had no end of problems. It doesn't connect properly to the serial port. I'm not dug into it, but I upgraded a couple days ago and got rather frustrated and ended up stomping on the computer because programs that were running quite fine on the last rev were not, serial Wi-Fi, and that's running an S3, but I then tried it on a regular ESP, and I was having results that were not good. I could not get it to be. Just got angry with it and said,
So when you first got here, the box was in a I'm not responding state. But now it's working again.
So plugging it into USB power seems to bring it back to life out of deep sleep.
Why would that be?
I don't know.
Is it glitch the power when you plug in USB?
It's now not functioning. That's what it has to be on. But if I plug it in.
Okay. But this behavior is not dependent. Has it connected with the Wi-Fi? Okay, so
Only when it's
not even, okay, so
only when it's
not even,
wakes up from deep sleep on a timer.
right. So it's not related to that.
So what does it need Wi-Fi for?
To send the battery status to data. So that I can monitor the battery.
Oh, so you can monitor at home the batteries from there.
So I can know when to recharge. My home inverter Peter just yesterday said, please It's recharge me, and so they wake up once a day, twice a day, to report their back.
Can I just clarify, Nick, the libraries that you had trouble with ESP32 libraries?
ESP32 libraries, I could not get a stock ESP32 library. I was doing the I2C scan, could not get it reliably. You know, it has always worked for me before. And under the brand new 5, I said, oh yeah, we'll upgrade to the brand new 5, whatever. And I could not get it, you know, it was getting to be very frustrating. It would not connect. And I had previous binary modules which I had not deleted, and these binary modules which I had not deleted, and they ran, but the ones made with the brand new version of the compiler did not work. I did not dig into it. I, you know, became angry and went out and looked for a
So the 5,
Treat a punch.
I just want to make sure I don't do this. And so I went, so it's
It's 5 dot
The-
something.
5 dot something, the brand
but
is
what's
4
before
to
5?
Yeah.
What's before 5?
4.
I mean,
Actually, technically 4.4 was
no. What word? So it's a blank
the last stable
Five.
release
Yeah.
of
way back.
Yeah.
IDE.
ESPID, so
Yeah.
expressive word.
Yeah.
IDE.
Yeah, it's
And
I decided to, you know, stupidly, I decided, oh yeah, I'll upgrade everything. I've been doing mostly Raspberry Pis. I wanted to see if some code I had running MicroPython ran ESP. And so I said, well, we'll upgrade to the latest and greatest version because I'm stupid. And
It's the latest and greatest version
of the ESP IDE.
of the
Okay.
expressive
Yeah.
ESP32 is the
Yeah.
height.
And I did not get the code to run. I did not delve into it.
You didn't down,
And I did not get the code to run. I did not delve into it.
you didn't downgrade to see it.
But you know what?
I have several computers. I only upgraded on one computer. I did not go back and run it on the older computer, run an older version, which I intend to do. It was just, I was trying to see whether my MicroPython code ran on the ESP rather than Raspberry Pi. And I could not get the examples to run. Now, you know, I have no.
So the MicroPython code was not written with the ESP in mind.
It is, no, not specifically. It was, I wrote a bunch of MicroPython code for the Raspberry Pi, and I wanted to see if it would run on the ESP.
Yeah,
Because I have lots of ESP.
that may actually be a problem in and of itself.
But I was trying to get, you know, some of the examples to work.
Just to interject something, I'm going to guess that Paul's not using the expressive AF. You're probably using the
Arduino IDE, but
Yeah.
Arduino IDE, but
Now, so that is layered on top of
The
an old
this says my
expressive idea.
libraries are 3.3.10,
okay, those
Yeah. Well,
and it says that my ESP tool is 5.3.0.
that's
it.
the one.
That's it. Okay, I'm
Yeah.
looking at the website, and that's about 4 revs back from the current. The current stable release is 6.0.2, but before that is stable release is 6.0.2, but before that is v5.5.4, 5.4.4.
I was running a 5 dot something. I can't tell you exactly what,
Yeah.
but I was having the code just didn't work.
Anyway, yours is about fourth in that list.
Yeah. And I can't report anything other than I got very frustrated. You know, I was trying to run stock examples and they would not connect and run.
So, I mean, that begs the question of what would happen if you,
Upgrade or downgraded.
downgraded.
Downgrade,
What
yeah.
would happen if Paul intentionally, what would happen if Paul intentionally goes back?
10 install ESP32, That's the
Somebody-
way they have.
Express that is not running their unit test.
Yeah, I don't, I'm fairly willing to admit that but when I tried to run stock examples, they did not run correctly.
One thing about the IDF you have to repeat to yourself periodically is they do not have a absolute contract for backwards compatibility. They are, when they're moving to these releases, in some cases, it's probably when they go to major numbers. So when there was the transition from 4.4 to 5.0, you had no ability to see the code would build and run properly. I mean, in other words, you had to you had to recompile, and then when you found out that the include file wasn't even there, go read the docs. Oh, this is how you do that now. Okay, so you have to refactor your code to take into account their changes. Take into account their changes.
They have too many CPUs and not enough programmers. They've got a whole range of.
But from one version, the 5.3.5 to the next 5 version, I believe they are trying to maintain compatibility in that and postpone the painful changes when the major release changes. Yeah, it lit up.
So that kind of worked.
Did you do it?
Oh, I heard it make a sound.
It's nowhere.
Oh, it's Mars. Okay.
It's just turning the lights off. Oh. It'll take a couple minutes before it actually goes to sleep.
Well, the way you describe it suggests some kind of power problem.
It's the kind of problem you see in the boot sequence.
When it was waking up on timer, trying to attach to Wi-Fi, failing, going back to sleep, it would get a software fault reboot.
Yep.
21, 12.
Yep.
And it would, when it wakes up from software fault reboot, it goes into normal gameplay mode, and the lights blink, this says play the sounds, whatever. So every 12 hours, I was hearing it say play the sounds, which I knew was wrong. It's not supposed to. It's supposed to wake up, but it's not. And so I had one test thing where, but it's not. And so I had one test thing where I would wake up on a timer and I feel we're going to do a micro that would go back to sleep immediately. And it got stuck in a infinite loop of reboots, software faults. So I know I've seen something for something speed to the screen that you can then push into a tool and it'll give you calls back and source code lines and whatnot. I didn't see that, so I don't know if I could turn something on to do that, or it was gone because it happened while it was
You have,
asleep. Or
is there a schematic diagram of the section of the hardware on the ESP that deals with using plugged-in power and the battery, and see if there's what hardware differences are in there, and if any of those might have a MOSFET that's not being switched on.
Or floating pin that sets it into some different mode.
Exactly.
And it's, that's not happening. There are some strange things.
it's also, so there's an on the board, there is a pin which is the battery, and a pin which is the bus, which is USB. Except when you're not plugged into USB, it's something out of a charging thing.
And it's got a rectifier and stuff.
Yeah. So I don't recall if I'm using anything off of that pin. I don't think I am.
But this is a new problem. You hadn't actually changed anything to do with that aspect.
No hardware changes.
Could there be a pin that's floating that you're not using that may be causing issues?
Yeah, it's a pin that, it's a pin that in the earlier version of the boot, the ESP boot was not done anything with, and in this version,
They're using it.
yeah, they're using it for something. You know, as I apologize for not having dug into the ESP problem. It's not a, but there was something was rotten in the fibes that, it could well have been me, it's in the fibes that, it could well have been me, I have stupid moments, but when I can't run the examples, I get a little angry. And
That's something that should work.
yeah, but I could load the Python to the ESP. That ran perfectly. So it wasn't the ESP, and I did that to both an S3 and a stock ESP, and the MicroPython came up and did exactly what it should do. It was just trying to run their examples in the 5 dot whatever I was running was causing me.
But that sounds interesting. That you said it's the IDE that changed.
Yeah.
Yeah, I wiped out my 4 dot, which I had used for a long time, and said I'm gonna go to the new version and be one of the cool kids. And
All the libraries, runtimes, everything.
I wiped everything and did a complete reinstall. I have multiple machines that have the old tool in, so I will go back and it's not like I destroyed my way home. It was just, that was the machine in front of me.
It's not strange.
Yes, and it was running MicroPython fine. It was running, everything was fine except for, and I regretted wiping it away. Everything was fine except for, and I regretted wiping it away, but I do have a backup.
Yeah.
Okay.
The next question is, can you find your way back?
Yeah.
There are a subset of the pins that you are able to wake up on. I am currently using 9 because that's how many buttons I have. There are a few more that I will use a little bit usable. I don't have external ports on my buttons. So there's some software that says
Pull them up and
disable to pull down, enable to pull up.
Yeah.
So I'll just,
Yeah.
I could try using fewer than 9, only try to wake up on this one. I can try pulling up the ones that are not using.
But they're not programmed to be interruptible, right? The ones you're not using, you're not.
I have a mask which says use these 9
Right. So I think that would be helpful. Again, you had not been playing with that, right? This is an area, it's kind of like the guy that the policeman comes up to him and he's under a street light, shuffling around, what's going on? Oh, I'm trying to find my car keys. And the policeman talks to him further, and it comes out that he was in a bar down at the end of the street with the lights went out.
yeah.
And
Yeah, it was working. isn't working. I don't know what the solution is. It could well be that some upgrade went in the past. I don't, I was, I will dig into my particular set of problems with one of my other machines, which I will not upgrade and see if it works. And I can just report suspicions of something ain't quite right. Yes, something nefarious, things that, their examples did not work.
I am having another issue unrelated to this project. So my irrigation controller is having some problems with it. I decided to replace my 8266 with the 8266 with a C3. I was almost out of C3 Ecos, so I said, let's try a C3 Mini, which has the same 10 outputs and whatnot. And I ported the code from the 8266 to the SP32. And when it attaches to Wi-Fi, it will say it's connected. It will then connect to the MQTT broker, and it'll send a message. I'll see that, and then it'll say, "I'm not connected to the broker. I'm trying to find outside." And then after trying 100 times or something, it'll say, "Oh, I'm not even on Wi-Fi. And so I'm getting one message every 5 or 10 minutes instead of every 15 seconds, rock solid, that I was getting with the 8266. And I think I was getting with the C3 Pico. So I said, well, maybe it's the board. So I tried a different C3 Mini.
Is there any metal in close proximity to the antenna?
No. And it's working now.
Oh, it's working now. So what? You're just, so it's a history
I
thing.
went to a C3 Pico.
Oh, okay, so you
C3
literally
Pico.
just changed the C3 board.
Yeah.
Because I mean, it sounded like very flaky communication. Geez, it's running on 3 volts. That's slick.
So there's the C3 Mini.
It's a chip antenna.
Antenna.
I don't see anything close.
So I tried 2 of those, and then switched it with the C3 Pico, which also has a chip antenna. It has the LiPo charging stuff, which I don't need for this particular application. And it's running fine. I haven't tried going back to these to see if it's still failing.
In case the camera can't see, you're running it with a couple of D cells, which probably runs for a good long while.
Yeah. Well, no. I run this with a wallboard. The D cells run the motor inside here.
Oh,
He was smart, used different power supplies.
that's right. And he hasn't blown his. What probably your other.
Probably using
Yeah. So that probably has nothing to do with this, but it's another.
No, point.
Strange from
You
going.
know, it's, let's say for the past 6 weeks, I've been using Raspberry Pis, the various, and
Because
yeah, Picos, and they have never argued. I just wanted that to be able to have some Wi-Fi access. So that to be able to have some Wi-Fi access. So that's why I was playing ESP LAN, and it wasn't a happy experience.
so I've had very good luck with the flavor of Pico that has Pico board
Mhm.
that has the Infineon Wi-Fi and Bluetooth.
Yeah, I've got some of those. I just
Real easy to use and a very pleasant experience using that.
Did you try swapping out the hardware on this problem, just in case?
I do have my development hardware, which is quite similar, not exactly identical. And I think I see the same issue on that one. I've forgotten which of my computers I've upgraded to the latest ESP stuff. I'm trying to not do it on both of them, but now I can't remember which ones. Well, so that
One number will be bigger than the other.
hopefully.
the other special thing.
Okay, go on.
Ken, I don't know whether I should have used this.
Where did you get the sounds from?
Online.
I'm like that.
I recorded them. I didn't do the snowing, but I did the play the sounds, Simon.
Yeah, I can tell it's your voice. Did the kids say, oh, that's Grandpa?
No. They probably recognize it. Any other comments, thoughts? I did think about, so I can do I have a little serial logger board that I could put onto serial 1
That would,
jump to that, and that would avoid the issue of Windows waking up to you
yeah,
and you losing others.
yeah, you need some way in, but generally intermittent problems like that, well, you can't, it's sad. It'll be something stupid, but,
Figuring out what it is not.
yeah, it will make you stupid.
All right. What'd you bring?
Well,
You're on.
me, okay. I want to be one of the cool kids.
Cool, okay.
Cool kids. So chemically, there is a process called recrystallization, where if you dissolve, which crystals will form. And for various reasons, I've been playing with recrystallization. So I have Peltier junctions, which one side gets hot and one side gets cold. And I can make one side. This is a thermocouple that if I tell them, and
Just a little.
okay,
7, 23.
yeah,
38.
33, and you can feel the difference. And the
Swap left to right.
problem
You're fine, right the way it is.
The problem is that you need to do something with the hot side. the heat. So I have remove the heat. So I have a big chiller, a scientific chiller that will do -15. And so I run these blocks, which I attach to the hot side, and I run highly chilled water through and through the block. And so once the hot side is reduced to -15, but it ends up being -4 because I'm dissipating the heat, but I can get fairly cold on that side. Now I have,
When you cool down hot side, does that make you cool down the cool side even more?
yeah, you get it's a temperature difference you get. The Peltier can dump heat, so you get a temperature difference of you know, depending on how you do it, 10, 15, maybe 20 degrees, maybe better than that. This is a slightly larger version. This is a 40 amp 12 volt chiller, and this will get water fairly cold. Yes, if you've got Peltiers here and you've got water blocks here, so you run water through the thing, and this was for chilling water. So this runs air through this side, blows, so you get hot air. The hot sides are connected to the fins, and this was, before I bought the chiller, this was for cooling water. And it worked fairly effectively. I don't quite need it at this point. This is a much larger cooling block that I'm using. And nicely made. And it fits 4 of the small square blocks. So you can stack Peltiers. Okay, so there it is. Yes, my children. This is a stacked Peltier. This is 4 Peltiers stacked together. This will, I've seen reports that this will do -90.
So basically, the hot side is coupled to the next,
To
to the next,
the next,
and so on and so forth. And so you create
a stacked.
voltage
Connecting
differences.
batteries together.
Right, yeah.
Yeah, but, well, it's like voltage drops.
Yeah.
And so you've got the temperature difference
And
across each junction.
that
Why the
is
different sizes?
because they're very inefficient. So each side, if the big one will drop. Yeah, these are the stacked Peltiers. The big one will drop 10, the if you think of it in terms of load, the big one takes a big load, and then the smaller one takes and so you get progressively. This is designed to be used. I have a vacuum chamber which has water cools, and so this is designed as a microscope based in a vacuum chamber. And the this supposedly will do -90 in air. I've read reports. I have not tried it. It depends upon your ability to suck the heat out of the other side. The cooling block in my vacuum chamber is big, and the fact that it's in a vacuum chamber means that there's it's very efficient. You're not losing any heat to the environment. So this is designed as a microscope base. You put your sample here, you bring the thing down, and if I could hit -90, I'd probably hit better than that because it's because I've got a good chiller. The chiller's running propylene glycol, which is antifreeze, and so it is in a vacuum chamber. If I get to -60, I'd be ecstatic. you can actually begin to look at individual atoms at that temperature without, if you try to look at individual atoms at room temperature in air, that they tend to get noisy and get things hitting them. In a vacuum chamber at minus 60, they're a lot less rambunctious. So this is designed for the vacuum chamber, but I have all sorts of different cooling blocks and different size Peltiers that's a nicely made cooling block.
Understand.
Do you have one?
I don't understand how it was manufactured.
I need to go on. You know,
They drilled some holes, but I don't know how they connected the chambers.
I don't. You know, they work. It works nicely. I don't. You know, similar. No, this is different.
It has holes.
Okay, yeah, it's
So this isn't just hollow inside, there's something in here.
There's a channel.
yeah. This is
Oh, a
Nick.
channel that goes
Yeah,
like this.
yep.
That's what all these things are.
Yep.
Okay.
That makes the big holes, but how they connect this channel with this channel, you
Well,
would have to go in.
this thing looks like it's probably all welded together,
and it probably didn't NC milling.
and they milled it all out in there, put a top on it, welded it shut, and polished it up.
But the you know, the fact it's got bugs in it,
Solid rock.
yeah, bugs in it.
Solid rock.
Yeah, I mean it's and these things are, you know, quite cheap.
So when beer is made, one of the steps requires the beer to be the liquid will become beer or worse, be cooled very, very quickly.
Mm-hmm.
I mean, the main thing is the boiling vessel might have 1,000 gallons.
You could,
And so you would need something, and they use a channel cooler very much like that,
Mhm.
only bigger, a lot bigger. And it's basically running water back and forth. Not water, but I mean, the liquid
Yep.
is running back and forth, and it's kind of passing as closely as possible to chilled water.
Yep.
Water
Yep.
That's going kind of,
I've thought of restacking this using the chiller that I have. I don't. I'm still sort of assembling stuff. I say this was.
And it looks, I don't see any joints. I think this is a solid
That was
rectangle.
maybe they drilled diagonally.
Yeah, that's what I'm thinking, because they're offset the.
Yeah, maybe they drilled. You know, they drilled. You know, at like a 15-degree angle.
So you think it started off as a solid?
Could well have, yeah,
They drilled holes,
and then plug the holes.
plug the holes. So my only question is, how do they
That one,
here to here?
Well, if they drilled at a 15-degree angle,
Yeah,
then they'd be like a V at the bottom.
because they're offset.
Yeah, but why drill all the way through? Then I don't know.
these things, this multi-stage Peltier device is on Amazon,
Yep, what do they get for it these days?
$77.
Yep.
107 degrees temperature difference.
Yep. And that's in air. In a vacuum chamber, it will get colder than that. Because
All right, Nick, well, when one of these fails,
I have a failed one. I will.
you give it to me and I'll go.
I have a failed one.
Do some exploratory.
Yes.
session.
I do have a failed one. But anyway,
how
so
does it fail? It's just a chunk of metal.
I left it connected to a pump for quite a long time, and I got some rust in the thing. And I haven't been able to get it. But anyway, these are I have many Peltiers. Yes. I have a couple other stacked ones, and I have I have one that's mounted in a spice ramekin, and it's it's a double stack Peltier and a ramekin with silicone steel around the outside and conductive epoxy holding it to the base, and then the base is attached to one of these, so I can put water into the ramekin. It's actually a very small copper disc in the ramekin, and I can cool the whole thing down fairly quickly. And these are accurate to a tenth of a degree. I've got ones that are much more accurate than this. And so I can, the aim is to be able to very, very accurately set a temperature just at the crystallization temperature. Yep.
Crystallize it.
Yep.
Can it be expressed in simple language how Peltier works? It's a backwards thermocouple.
Yeah, it's a backwards thermocouple. It's you've got two dissimilar metals that the energy tends to flow from the more active metal to the less active metal. And this is just, I don't know the exact way this is built, but it's just like one of these thermocouples. But it's a thermocouple, if you put voltage across it, will get cold. These are tiny because they have very low thermal inertia.
And these are arrays.
Yeah,
Wondered.
Arrays.
I'm sorry.
These are arrays of joints.
Yep.
So imagine dozens of those thermocouple junctions.
Yep.
Lined up with their hot side.
We're facing the same direction.
Yeah, all well, consistent.
Yep.
If you change the polarity of the power, it swaps, which is hot.
Inverts is great.
Yep.
Yeah.
I've been always wondering if a Peltier system, this is just a pipe dream thinking about our current climate change issues, but if a Peltier system could be used in a heating or cooling system.
Very inefficient.
Yeah.
Well, see, that's the question. Is the amount of electricity needed so high that the cooling effect just isn't, or the heating effect isn't worth it?
These are only used in specific where you want to control it very exactly. A phase change freon system is much more efficient. These are 8-10% if you're lucky.
In terms of consumer devices, you see them in specialized refrigerators that are designed to operate like powered off of your car battery in a camping situation, or it'll keep bacon and a few other things cold. But it requires a considerable amount of power to do that. But the portability of it, and the fact that you can make one that's literally lunchbox size is in extreme contrast to the typical heat pump or refrigeration system that has a relatively large minimum size because you're using compressors.
I'm just wondering what the efficiency ratio is.
It is, horrible effect. I have a chiller, which is a compressor that I use as a first stage to give me.
So I can see why it's never gone beyond.
Yeah,
It's
The specialty.
heavily used
usage.
in special applications.
I have one for an insulin chiller. It keeps my insulin slightly cold, and
Others have made.
It keeps my insulin slightly cold, and
Others have made solder paste chillers. The Spark Fun guys made a Peltier based chiller, and it was just a little Peltier refrigerator that was big enough to hold a few pots of solder paste.
Or they want to keep the solder paste cold.
They,
It-
it extends its life.
Yeah, it doesn't like to,
Yeah. Makes a big difference. In terms of lifespan of the, it kind of incredifies with heat.
So the reason I was looking at my drip irrigation thing is it would, so there's a little motor in here that turns this little like this. Then there's a shaft position sensor that tells you when the valve is on or should, position sensor that tells you when the valve is on or should off. And it was not turning off or not turning it on or whatever. And so if you can see,
That's a fractured solder.
that is a fractured solid.
that's not good.
It's frustrating. And it takes a while to find it. Rating. And it takes a while to find it.
Yes,
Actually, this one over here was fractured, and I saw it and fixed it and put it all back together, and it was still doing the same thing.
Yeah.
So I looked again and then found out. What's weird is that these two are the switch two leads that go to the motor. Well, that's fine.
Yeah.
I don't know. 30 cat 3 cable.
I tend to use, when I got the wires the way I want to, I resort to a hot melt gun.
So are you gonna fire this thing up so that we can watch it generate frost?
Well, this will, yeah, I mean, this is, I don't know how cold I can get without a sink, but, that's,
4.5.
yeah, I mean, let's see, I don't get the thing too hot.
That's at 22.
Yeah, I mean, it's, I'm running, that's 4 volts. It's running at 4 volts, and okay, I hit 18,
Still cooling.
it's still cooling.
Is that like a Fahrenheit night? Is that like a Fahrenheit night?
Yes, it does.
You can't convert that on the fly.
Yeah, it's
5 nights times 18.
What kind of beer are you still using
42
Fahrenheit?
9/5.
Yeah.
9/5.
I'm 18. If you, the hot side will be hot. The hot side's 40. The cold side will be quite cold. I hit 19.
40 degrees.
Yeah. Let's see. This is set. I can change it, but I can't think in Fahrenheit anymore. It's
Well, 22 is a very nice room temperature.
Yep.
It's in the 70s, low 70s.
Celsius.
and
Centigrade in the old.
22. Then having to switch back and forth. Europe's been having an amazing heat wave in the middle of the World Cup. So it's affected the World Cup games here because it's hot as all get out. Some of the games are
and we're Fahrenheit, so it's hotter.
Houston, Texas. Yeah. Well, and then in England and Germany and so on, they're roasting because they're seeing low 30s. When it starts getting into the mid 30s, they begin
Dying.
declaring, yes, literally because they've got very little AC, and
They're not. The Europe isn't big into AC yet, but with the whole global,
Really, they don't use that much AC.
no,
very few places have good AC.
no, I mean we're talking about latitude 53, 54 degrees north.
Right.
So it's like
They don't get enough cold weather to make it worth it.
southern Canada.
Yeah.
So can you show or say how you hooked that up and how much power you?
Yeah,
set
well,
to-
it's at the moment,
So if you look up on the screen for a second, that box in the middle is kind of blocking the, I can't, yes. Okay.
okay.
Okay,
And
that helps.
just a further improvement.
Oh, it's gonna. Weevils.
Oh, yeah, no, it's,
No. Digits or anything. Digits or anything.
yeah, you can, my amp thing is not working. I'm not quite sure why, but I'm definitely getting delta.
Let me see if I can camera.
I mean,
Hey, look at that.
yeah, I think of these,
Reverse video.
yeah, I think of these things in terms of heat load, in, how much,
That's backwards.
Oh, that's right.
Yeah, that one's backwards, yeah. Mine isn't though.
That's why I was having a hell of a time steering the camera earlier.
Yeah,
yeah, I mean, there reaches a point where the self-heating, where it basically doesn't work. You can't pump infinite power into the thing and there's a point of diminishing returns.
So what's coming out of your power supply? How much?
In this case, I'm running 3-4 volts. The amp meter is not telling me how many amps I have. We'll try hitting it.
That's a 1950s service technique.
Yes, work with tubes. But it's, let's say this one, the big one, is running 12 volts at 40 amps. Take big wires. The wires get warm.
Okay. Go to settings.
You
And in settings, go to
You don't
video.
have to do that.
What?
It only reverses it on your computer. So
No, you don't want to reverse that.
the recording will show it correct.
Oh, good. Okay. So
Okay.
yeah, but
No,
so hey, Scott,
this is wrong.
Yeah.
where's the thermometer? Hey, Scott.
But if you flip the camera, I'm gonna get the flip in the recording, so you don't want to do that.
Hey, Scott. Can
Yeah.
you read that voltmeter? I mean, that's this temperature.
Can you hear me?
meter? Yeah, I can hear you now. Can you read that? Is it 54.5 for you?
Some,
It's
it's either 53.2 or 53.0 or,
Yeah, there's one thermocouple's on the hot side, one's on the.
yeah, it looks like
Near
3 full digits.
Yeah. So the top number is a normal number. It's not mirror image. All right, that's great. So the monitor inside the meeting room.
No, it's not mirror image.
Yeah, well, but if we walk
It's not
over
the
here to
monitor,
our
it's
monitor, and we
probably
look at that, that is mirror monitor, and we
probably
look at that is mirror image.
Or Paul's shirt,
My
actually.
shirt's my shirt is backwards on my screen only because that's how people like to see it in the mirror.
Oh, and you can turn that off, yeah.
Turn that off if you
Yeah.
want.
Right. Right.
Well, your shirt is forward for me now.
Yeah, everything is cool.
Okay.
Well, it's all fine.
We've been struggling the last few months to understand Jitsi in corner cases. And so it's good to understand. When
It's not just
get
Jitsi, it's a whole bunch of things.
Yeah, modern life.
It seems like every single service that uses a camera, my view of it, this is within Zoom and Discord and everything. My view of my camera is always backwards or mirrored, but
What you expect.
everyone else sees it normally.
Right, that's what you would expect.
It's funny. My skin.
And there's actually a setting somewhere, somehow, where you can. There's a setting somewhere, somehow, that on your phone that you can set it so that all those images that go out the stream
Fine.
are what other people see.
Yeah, I think there's some idea that if you prefer seeing yourself, the only time you see yourself is in the mirror.
Okay.
And so people tend to prefer seeing themselves backwards, reversed, and so that's why they do that on your own screen.
Right.
Well, I noticed that a lot of TikTok folks and Reddit folks, they want to see themselves as others see them, and that what they ends up posting mirrored.
Yeah.
Yeah, that's the fallacy of wanting to see yourself like other people do.
So I like to watch,
Get used to seeing yourself mirrored.
yeah, there are YouTube video collections of stupid car accidents. And occasionally, the person making the compilation will mess up his settings. And, the action is taking place in Russia, but they're driving on the left side of the road. That had me going for a while, like, is there a part of Russia where they drive on the left?
Now, what's interesting is that here at work, they've got our cameras set so that we see ourselves correctly, and everyone else sees ourselves correctly.
Yeah, you can do that. I think you can actually do that on Jitsi. If you go to your camera setting.
Yeah, it says everyone chooses the mirror.
Yeah, it says mirror
That
my
was when I
video.
Yeah, I
started.
think all of them can do that.
Yeah.
Yeah, I was in the middle of having Dawn do that.
What's on your screen, I believe, is what is recorded.
Yeah.
So if you want, you have to put this tile view if you want, like Scott to show up view, but whatever. That's not what's on your.
So, I just grabbed a whole bunch of, I was gonna bring, one of my nitrogen lasers, but I didn't get a chance to get it to the way I wanted it. I wasn't gonna fire the laser, but I was gonna go through how it works. It puts out, a pulse, which is about 3 to 5 megawatts. Yeah.
So back on momentarily on the subject of cooling, chilling. Back when I made all grain beer from starting from grain, and my solution for how to very quickly chill it was to run copper tubing through a big chest cooler full of ice. And the heat of fusion of ice when you're running it backwards is very powerful. It's is it 80 calories per gram
It's
So-
yes,
for every gram of water for every gram of ice. The energy needed to
melted.
melt the ice takes 80 calories of heat out. So it is chilling the copper tubing very, very, very powerfully. And I was able to bring 7 or 8 gallons of stuff from boiling temperature to 60 degrees in a very short amount of time. That
Running it through the loop
Yeah, so
several times or just once
so the
on the hot side of the cold side?
okay, I actually I left out a big detail. So unlike a plate chiller that we were describing, the water's not running through the chiller. So I had a bunch of copper pipe in the ice, and then a coil of copper pipe in the boiling liquid, and then ran water through it. And the water would be chilled on the way through the ice, and then chilled on the way through the ice, and then circulate out, and then dump into a drain. And it would basically chill the metal pipe in the hot liquid extremely efficiently. So it was like a plate chiller or an inefficient definition of plate, right? So we couldn't get the interface was only as wide as the pipes in the coil.
Right.
Okay, so now you're powering up the stack.
Yeah, I just have,
You got that.
yeah, this is the stack one, is, and I doubt whether I'll be able to get,
Temperature differences.
What's the value of,
Temperature differences.
what's the value of putting the tape on there?
these thermocouples.
So he's measuring the hot and cold side
Yeah.
Oh, okay.
of the device.
Yeah, this is,
Oh, you got wires attached.
These are the two,
Yeah.
temperatures, but the difference in temperature is very small.
yeah, the heat load is how I think of these.
Okay, let's try one quick experiment. Where's that big block of it?
Yeah, but it's,
This,
yeah,
put the hot side on that.
yeah. It's,
Whoops.
pull the electrode off the hot side so you get a good contact.
Okay, now, now the difference jumped at about 10 centigrade.
Mm-hmm.
Although the camera is,
That's better. Oh, now the temperature difference has gone away. Oh, your finger,
Yeah, probably
your finger is
is heating it up.
heating the cold side.
Yeah, I mean, the heat load on these, is the ability to pump heat,
Crank it up a bit.
You want a small thing?
Yeah, I can feel it getting very cold.
yep,
So that's 21,
19,
19 and versus 33.
yeah, well, if we've got
So we're keeping the
16.
hot side pretty cool.
Yeah. 16, you know. I say this one supposedly will do a difference of 100.
Yeah, so it's 25 degrees centigrade difference
Yep.
now, and it's rapidly.
It's getting cold.
Yeah. So down to 7 centigrade.
Yep.
All right.
Let's say this one, if you run this in a vacuum chamber, so you've got no heat escaping on a gigantic chilled block, which is what this is meant, what I mean this to do, it will get very, very cold. And I have thermocouples in my vacuum chamber, so I can look at how cold it's getting.
So a few years ago, I made a gadget similar to this, only instead of this thing here, I had the heatsink assembly out of a CPU.
Mm-hmm.
And had it the hot side of the Peltier, some of that
Thermal paste.
thermal paste gunk. And then the cold side was just left exposed. And when I turned it on, and I don't remember what it was, 8 or 10 volts maybe.
Frost.
Oh, and there was a fan on the heatsink. And it was so effective that I could stick my wrist on the side of the Peltier with a thermocouple and drop it down to about 5 Fahrenheit. And it will trick your body into, it will break you out if you're having if your temperature regulation is messed up, your body's overheating, and you chill your wrist, it will often break you out of that.
What have you got? The things.
oh. This is just a toy that I just received as a birthday present. And so it is a card computer, and this is an ESP32, but let me just show you the most fun thing. There's not much on here. So it has Wi-Fi capability, Bluetooth, RF. I don't know what that antenna is, LoRa, FM, and IR. Okay. And so the only code that's put on here, so far, I don't know if you're familiar with the TV Be Gone.
Oh, yes.
Well, my son and I were just on a road trip, and coming down to have breakfast in the morning with the TV blaring just drives crazy. And I had mentioned seeing one of these. And so anyway, that's an IR transmitter that's hanging off of it. And so the next time I get a situation like that, I can take care of it all on my own.
That's awesome.
Anyway, I read all kinds of things that you can do with these little computers, but I haven't tried to do much with it. In fact, I only got it 2 days ago, so I haven't done anything with it. There's little arrow buttons down at the bottom that
What's this?
that's the ESP32.
Oh, okay, yeah.
And it has all kinds of ports. And then the bad thing is you have to manipulate those little tiny buttons. But it's not too bad with your, that's your screen, which is not enormous.
And in the same vein as the TV be gone, virtually everybody in this room is probably familiar with the owner of Adafruit, Lady Ada. Well, Lady Ada got a master's at MIT, and part of her thesis was a cell phone be gone. And it was, the principle being that a person should have a little bit of privacy in their private personal space. And so you have this device with you, and when you turn it on, there will be no loud cell phone conversations. And there was controversy over publishing the thesis, but they finally said, let's get real. It's between whoever's going to make one of those and the FCC. And the FCC has no sense of humor at all. Like $10,000 fine.
Other than Homeland Security.
Does it do block the signal?
Yeah. I mean, yes, it jams the cell. It jams the cell.
You can jam the cell phone.
Absolutely.
Yes.
Well, here's a little known fact. I mean,
Well, it was easy with the earlier cell phones. Jamming 5 gigahertz is,
but bottom line is, any RF receiving device is absolutely
Jammable.
dependent on signal strength differences and or the timing of the differences, and being able to detect the difference between signal and noise. And if you provide sufficient signal,
Well, anything that's frequency modulated, though, would be more difficult than amplitude modulated.
but the bottom line is, if there's a strong enough RF field, it basically makes it impossible for the receiver to operate. So I don't know. I don't remember even looking at the schematics of her device and whether or not it was, a strong modulated signal of some sort to scramble. I don't know. I have no idea. But all that's actually necessary is enough signal to make it possible for the receiver's front end to work. The front end has to be this notion of signal to noise ratio. And if the noise is up here and the signal is down here, you're just toast. The signal is down here, you're just toast. Yeah.
TV signals, though, are interesting because they use both AM and FM in their modulation schemes.
Gotten very sophisticated.
There are parts of the signal which are AM, parts of the signal which are FM.
Yeah, and in fact, they're using many more states than 2, right? So it's a lot of bits per baud. Is one way to put it.
And the actual bit rate changes depending on where in the video image you're dealing with.
My brother still uses off-the-air digital TV, and he has all kinds of gizmos on the edges, and he's always talking about, the latest upgrade, that apparently some of the area stations are staying very up to date on the standards and so on.
Back in my old days, being a broadcast engineer,
There's a guy,
broadcast engineer.
there's a guy, he has a YouTube channel, and he's very wealthy, but he has rebuilt the up and down link for the Apollo, and goes into great detail with the numbers of channels they get, and I follow.
Apollo?
Well, Apollo, yeah, he's got old Apollo computers.
Oh,
You know, he's rebuilt out of old NASA parts the entire up and down link for the Apollo.
You want to hear something weird? My dad worked on
I'd love to,
the
to see somebody do it for the Pioneers.
yeah, that would be step one, get a 60-foot dish, right? But, no, my dad worked on the Saturn V instrument, and that was a bunch of gadgets at the top of the Saturn, actually the second stage of the Saturn. And one of the devices was the transponder, which received signals from the ground and retransmitted them on different frequencies. So it would, and basically it allowed on different frequencies. So it would, and basically it allowed communication links where the spacecraft was acting as the relay station. So if someone in location A in country number one could talk to somebody over in country number two, because you're bouncing the signals, are not bouncing, but going through. And this was going on in Huntsville, Alabama, and when they got to the testing phase, they took this mobile dish antenna, it was about like a C-band TV, satellite TV antenna, so it was like 8 or 10 feet in diameter. And then there's a mountain alongside Huntsville. They drove up on this mountain and pointed the dish at Marshall Space Flight Center, which was 25, 30 miles line of sight. And for whatever reason, they didn't think about power level. So when they first turned it on and, did effectively the key down and it started transmitting, they asked Marshall, do you get a signal? Marshall, do you get a signal? And they say, like, they were joking, of course, but there's smoke coming out of the receiver. Because it was designed to transmit across thousands of miles, and they were doing 30 miles, and their effective radiated power out of this thing was, I don't remember the power. At the time it was amplified. I mean,
maybe we don't need to have that much power.
Exactly. I mean, the dish antenna would have 25 or 30 dB of gain.
Yeah.
Which is a factor. 30 dB is a factor of 1,000 gain. So if they were running, say, 100 watts, then it would be effectively like 100,000 watt signal. And so this back about this time I was very keen with motorcycles, and I drove up to the mountain, and I drove down. It's actually on Green Mountain. The main mountain's called Montesino. Anyway, I went down on this fire trail where these guys had set up. This line of trees had a giant burned, off-color of leaves. The leaves had changed. It wasn't October yet.
I had a boss who was in one of the Gemini horn antennas.
There was on Long Island. There was a base that they used was a base that they used for tracking submarines or whatever it was, and they had a problem with the transmitter. And the guy went out there to check, and he never came back.
Yeah.
And when they went out there, they saw this corona coming out of the antenna. There was a break between the transmitter and the antenna, and there was so much power that there was a corona coming out like this all the way around to where it was supposed. And the guy, there was a ladder, and his body and his head were separated on the ground. This corona came out and literally sliced his head off.
Yeah. So picture in World War II, Southeast England B-24 base, and the B-24s had radar, but they operated them very much lower frequency than that base, so there wasn't any hazard to eyeballs or anything. But it didn't take the ground crew very long to discover that they could turn that radar on and stand in the focal point of the antenna, and it would warm them up.
Well, they used to use that. They use it last now.
You're right, about age 19 years old.
Yeah.
Yeah, I mean, the
19 years old.
Yeah.
Yeah, I mean, the experienced pilots were 22, 23. My dad was 20. Time.
We got a young girl that lives on our block who loves getting her younger sister and her in the car and flying up and down our dead end street at like 35, 40 miles an hour, which they think is perfectly fine. But on a back street, 10 to 15 is about it, is all you should be doing. My wife yelled at them once and they got insulted.
Well,
It's like, come on.
it's
Darwin,
down to your
you know.
pets and your children, all the cops.
Well, yeah, you kind of,
You know,
when it's a neighbor, you don't want to start bad.
but what's the value? You know, what is the savings?
The thing is that there are little kids and small animals on the street
Right,
all the
exactly.
time, right?
Yeah.
So you shouldn't be doing that kind of crap.
Yes, we used to live on a street named blah 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 circle, except that the developer changed his mind and it wasn't. We were within a few yards of the end of that cul-de-sac. And cars would come down and they'd be going 50 as they were approaching, and suddenly realize, oh, this isn't a circle. I've got 200 feet, 200 feet to stop. Yeah, over and over again, and one of these things where statistically someone's going to get.
Well, that's the thing.
Okay,
I mentioned the maze robot. This is
well, all right.
Is this the new one you're putting together?
together.
It's a is a tail.
It's articulated steering.
Oh, yeah.
There's a servo here that wiggles the back from the front. When I modeled it in CAD, I have another one back here. It's called my Caterpillar. I have another one back here. It's called my Caterpillar.
That would be
Robot.
interesting.
So I made.
Are there independent motors on the wheels
There are.
so they can turn in either direction?
You can.
So
Each wheel has its
you
own
can
motor.
turn on a dime and give 9 cents change.
Well, except there's this thing hanging out that doesn't want to go this way.
So
So
that one doesn't have motors on it, just the back ones.
That's right. I just saw that. Yeah.
the front, this is the front. And so to do a turn, I think I will.
So in a sense, you're still doing skid steering. Because the back wheels are connected together.
They can turn independent seconds, though, I think, aren't they?
Which
The blue wheels. Do the blue wheels have to turn together? Or do they each?
well, they currently do because they're pressed fit onto the.
Oh, okay.
So it is skid steering.
Yeah, there's no differential.
And move, does it, yeah, oh, there's the syrup. I'm so excited. I'm so excited. You all can have entries in the macro mouse competition, you know that.
Is that, so that, the name of it is Macro Mouse?
Yeah, there's a micro mouse in Japan that's very high speed and very little. We're doing bigger, slower, less complicated this year at least. We may graduate to micro mouse, but if you saw a micro mouse, you'd be going, wow, I'm not sure I can compete with that. I mean,
Yeah.
don't you feel that way a little bit?
Well, just speed up the video.
What they do is they have the maze, which is more like a real maze with a target in the middle somewhere, and lots of cycles and loops. And you release your mouse, and you get, I think, 4 runs where it's learning, where it just does the maze, and then the 5th run, it runs it for time. And the ones that they do, I mean, time. And the ones that they do, I mean, they're amazing. Like, they'll run down a zigzag like this, learning, and then to actually run it, having figured out that there's a diagonal there with enough clearance, they will hit it and they will turn on a fan to suck them to the floor and shoot straight down the diagonal, not taking any of the corners. Then at the end, just turn to wherever the path is. I mean, you should watch some micro mouse, but we're doing macro mouse. It's a different thing.
All
They
right.
don't necessarily go the shortest path. That's not the fastest path. They go the fastest.
Right? They compute the fastest path. So a longer path that has a diagonal like that in it is sometimes faster because they can get up to speed. I mean, you could put a micro mouse competition up there. There was a TED talk on it that has some really good ones. And we're doing macro, which is 10 inch by 10 inch, and you come in and you come out of the maze instead of going to a central point, because our vias are going to be 16 inches wide. So you have to make a really big maze to have it go to the middle. So it'll be like a 12-foot by 12-foot maze. You go in one place and your goal is to come out the other. And we've talked about there's a remote control version where you're in your own class when you drive your robot. So the human's doing the navigating. There is we're proposing an on-time version, since you know in advance what the maze is. So you could even dead reckoning down the maze. Is you at the beginning, you put your robot down and you declare, my robot will finish in 2 minutes and 13 seconds, and then you turn it on, and your score is deviation from your claim, and then there's fastest. And we might have a trained one. We don't know if anybody wants to do training or not. You want to do training? Okay, we'll have a trained one. Anyway, so that's kind of what's going on. Sorry, so, and we're going to do, it'll start in September. We'll have workshops over the fall on Saturdays, probably in the mornings, and then right after November, so like in early December, we'll have the actual event here with 2 fields set up and sort of like sumo, but with macro mouse. So anyway, thank you for letting me interrupt your whole meeting and tell you about it. But I can't believe any of you wouldn't want to put a macro mouse competition in, entry in. You can have a zoom up camera and learn the whole thing by looking at it and then just drive it. And just see you're going to do that now. There's no rule against that.
I have, see here first, one of the,
He'll put a laser on it and cut holes.
no, I have one of the STM neural processors.
There you go. There's no rule against that.
Okay, it's, I haven't really explored it, but, and I have it to look at plant samples, but,
Well, go for it.
you know, it's it's got some heavy image processing. People are using it for interpreting sign language.
Cool. So do you all need the shop, or should I lock it? Close the back door and turn the light off?
We won't be using it.
I'm gonna close up the shop and then Oh, okay, thank you.
Here they are.
I'm sorry to run, but I gotta go, but thank you for letting me run.
Thank you. So here they are,
This micro,
Yeah.
Micro Mouse, yeah.
Yeah.
Micro Mouse, yeah.
Chatham.
So, oh, wow, it was one of those diagonals.
Yeah.
It's also very, very small.
what does that do?
This is Claude Shannon with an electric mouse. Claude Shannon is one of the theoreticians that is one of the theoreticians that figured out difficult things to do with the nature of communication.
Yes. Do I need to do something or you were signing?
I can't assign it, you have to take it. You know,
This is Macro Mouse.
micro, is that micro or
No,
macro?
this is Macro.
Oh.
Claude Shannon was one of the first.
You can, if you,
One of the first.
you can, if you, people do for mounting, I think it's an ESP to the back of a copy. Through it.
Yeah. Now, if you can make it autonomous, then it'd be even, better.
No. this-
Well, I mean, it's,
Yeah, yeah, do you know, oh yeah, you're fine, yeah, you just do it.
It's improved
You could
now.
all use your, you like that?
Okay. As soon as he comes back, we can declare victory.
We can declare victory and,
Go ahead and turn off the recording. Oh, you can do that, right? You have to
The only way to do it now,
pray and shut down.
exactly.
So it's-
That is,
or shut down and pray, one of the two.
Yeah, so close the browser tab.
let me just,
Yeah, so close the browser tab.
let me just double check. Yep, there's no shut off video.
Right, but if you go over to your downloads file,
Isn't there a machine instruction for that?
Yes.
so how about,
Shut down and pray?
Hang up and let's see what happens.
do it ls-o in downloads and see if you've got your.
Well, I've been doing that periodically.
Oh, okay, so it is getting fast.
So, yep, periodically.
Oh, okay, so it is getting fast.
So, yep,
Okay,
we've got like 66 million bytes of video.
all right, well.
All right, I'm gonna shut down and